welcome back to Mathematical Monday Mornings, and we are your hosts for today's episode. This episode we will be discussing about the different types of linear inequalities in two variables. We will be giving three problems with increasing difficulty, their solutions, and their respective answers. We will now start the show. Easy problem. Okay, so first of all, here is our first problem. Graph the solution set of negative 2x plus y is greater than negative 4 and 3x minus 6y is greater than or equal to 6. So first of all, we want to isolate y to one side and the rest to the other side. So we will be simplifying them. So this will become y equals 2x minus 4, since we let y stay here and transpose 2x there. And then simplifying the second inequality, which will become y equals 1/2 x minus 1. So basically we just added 6y to the other side, then subtracted 6 here, so it becomes 3x minus 6 is equal to 6y. Then we divided both sides by 6, so it becomes y equals 1/2 x, since 3 divided by 6 is 1/2, minus 1, since negative 6 divided by 6 is negative 1. So we have our simplified inequalities here. So to facilitate the graphing process, we will use a dashed boundary or line defined by y equals 2x minus 4 and shade all points above the line. So the y-intercept is negative 4, so we will mark a point in the y-axis, which is there, negative 4. Then the slope, which is 2, since that is m, so it's rise over run, so it's 1, 2, then 1. It will intercept at the x-axis at point 2, which is right there. I apologize for my bad dots. So we will define it with a dashed line. So dash, 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 dash. I apologize for my not so straight lines. My mouse isn't that accurate. And dash, 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 downwards as well. Arrow. Then we will shade all parts above it. So let me thicken the size, then try to shade it at least. I don't want to use the fill since it will probably get messed up. Okay, so this is the graph of the first inequality. Okay, then for the second inequality, we will use a solid boundary defined by y equals 1/2 x minus 1 and shade all points below it. So the y-intercept this time is negative 1. We'll use red this time. So negative 1, and the slope is 1/2, so rise over run. So the x-intercept is also the same as the first inequality, which is 2. Then we will draw a solid line connecting the two dots For the second inequality, we will use a solid boundary defined by y equals 1/2 x minus 1 and shade all the points below it. So the y-intercept is -1, and since the slope is 1/2 rise over n, it has the same x-intercept as the first inequality. Then draw a solid line. So it'll become, oh, that line is not that straight. There. Okay. And shade all the points below it. Let me increase the size. Okay, so we got our two graphs overlap, the first inequality and the second equality. So what we're finding for is their intersection, since the problem said end, which is intersection, and the intersection is this area right here and onwards, since the graph is only small. So I'll use pink, kinda. The intersection will be shaded pink. Okay. Now here is the graph of the intersection of the two inequalities, respectively -2x plus y is greater than -4 and 3x minus 6y is greater than or equal to 6. Okay, so our medium problem. The graph the solution set -2x plus 3y is greater than 6. Let me just write it down. -2x plus 3y is greater than -6. I'm sorry, is greater than 6, and 4x minus 6y is greater than 12. To start the solution, we begin by solving both inequalities for y. So we substitute again. So it basically becomes 3y is equal to 2x plus 6. Divide everything by 3, so it becomes y equals 2/3 x plus 2. Then we simplify the second inequality, so it becomes 6y equals 4x minus 12. Then we divide both sides by 6, so it becomes 2/3 x minus 2. So as you can see, both inequalities are identical, but the only difference is the sign. And you will see a weird pattern at the end of the graph. So we got our simplified, inequalities, this, and we will begin graphing them. So for the first inequality, we will use a dashed line for both. Actually, we'll use a dashed line for both. And for the first inequality, we will shade all the points above the boundary. So the y-intercept, which will be in blue, is 2. So that's that. And the slope is 2/3, rise over n, 1, 2, 1, 2, 3. Then use a dash line to connect two dots. There and there. Okay. For the second inequality, We'll also use a dashed line and shade all points below it. So we will use red this time. The y-intercept is -2, which is right here. And the slope is also 2/3. So it's rise over run 1, 2, 1, 2, 3. Then complete it with a dashed line as well. So as you can see, both of the lines that connects the dots are parallel to each other, leaving a tiny gap in the middle. Okay, now we will do the shading. I forgot to do the shading. So this one we shade all points above it. Then for the second inequality, we'll shade all points below it. And my shading's amazing. So as you can see, there is no intersection of these two shaded regions. Therefore, there are no simultaneous solutions. Basically, the answer is the solution set is null set, or you could also write it as 2 braces. And yeah, that's the answer. Our hard problem. So the hard problem is graph the solution set of y is greater than or equal to -4. So let me write it down real quick. Y is greater than or equal to -4. Y is less than x plus 3. And y is less than or equal to -3x plus 3. So all of them are already simplified. It'll be easier for us. So we will start graphing these 3 inequalities. So the first one is y is greater than or equal to -4. So as you can see, there is, wait, hold on. We will use blue again. So the y-intercept is -4. Since there is no slope, or I'm sorry, the slope is equivalent to 0, it'll form a horizontal line. The slope is equivalent to 0. And shade all the points above it. Alright, so that's the first inequality. Now we will graph the inequality y is less than x plus 3. We will use red this time. So the y-intercept is 3, which is right there. It's so big, lol. Okay, and the slope is 1. So 1/1, so that's where it connects. Then use a dashed line. So dash, 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 and another dashed line. There we go. And shade all the points below it since the sign is less than. Now the third inequality is y is less than or equal to -3x plus 3. So the y-intercept is plus 3. And the slope is -3, so that's 1, 2, 3 overrun, which is 1. And we use a solid line. And shade all the points to its left. So as you can see, there's so many things going on, but all you need to do is the intersection, which is this triangle right here, and we will use green to highlight the intersection. Alright, so that is the intersection of all three inequalities. So the graph suggests that -1, 1, so -1, 1 is a common point. As a check, substitute that point into all the inequalities, and it actually does verify that it solves all three conditions. So that is the graph of the intersection of all the three inequalities. And that sums up our tutorial video. We hope that you've learned at least a bit in solving linear inequalities in two variables by graphing. I want to let you know that graphing isn't the only process or method in solving linear inequalities, and there are many other ways. We have been your hosts for today's show, and as always, thanks for watching.